Hi students, Vinya ma'am back with quantum numbers. We'll have a quick review of what we have learned. Principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number are the four different quantum numbers required to explain the structure of atom. The behavior of atom is identified by the principal quantum number, which is denoted by the letter n, which can take values 1, 2, 3, etc. up to n. And so you find that these are denoting the energy levels or the shells, whereas azimuthal quantum number, which is denoted by the letter L, can have values starting from 0, 1, 2, 3, etc. up to n minus 1. A total of n values are there, and you find that this helps in identifying the shape of the orbitals. Coming to the next one, that is magnetic quantum number, it helps in identifying the orientation of the different orbitals, and it is dependent on the L value and it is denoted by ml, and it can take values starting from negative L to positive L through 0. That is a total of 2L plus 1 values will be there. And finally we have the spin quantum number, which is denoted by the letter ms, which is having two different values, plus half for clockwise spin, and if it is anti-clockwise it has the value negative half. Having said that, we also have the idea that each and every orbital can have a maximum capacity of 2 electrons. That is, the maximum capacity of 2 electrons are possible. Now we will learn how to write the quantum numbers for different electrons in different orbitals. Starting with n is equal to 1. When n is equal to 1, the L value taken will be 1 less than that. So it will be 0. And if L value is 0, ML can have value only 0 because it is dependent on L. So ML is negative L, 0 and positive L. So here if L is 0, you find that negative 0 and positive 0 is not there. So ML becomes 0. Now coming to MS. MS will always have plus half or negative half. That means in a particular orbital we have two different electrons. Now we shall see L value is equal to 0 denotes S orbital. And so this particular orbital having the following quantum numbers can be represented as 1s, and it will have maximum capacity of 2 electrons, which we will represent it as a box. 1s can have 2 electrons, the first one with the positive spin. So that means if it is a positive spin, we show an upward arrow. So the first electron in the s orbital will have n value is equal to 1, L value is 0, ML value is again 0, MS value is plus half. Coming to the second electron also has n value 1, L value 0, ML value 0 and MS is negative half, which is denoted by a downward arrow. Hope it is clear. When n value is 1, it denotes that it is the K shell which we are referring to. So in the K shell we have only one orbital, that is the s orbital, and it can have a maximum of 2 electrons. Now the different quantum numbers related to the second orbit. That n value is 2, it denotes the shell is L. And L shell can have a maximum of 8 electrons. We shall see that what are the values for L. When n value is 2, L can have values starting from 0 to 1. That is 1 less than the maximum n value. So L can have 0 and 1. And if L is 0, it denotes it is an s orbital. L is 1 means it denotes a p orbital. Now we shall see what are the values for ML. ML, if it is if L value is 0, then ML can have only one value, that is ML is equal to 0. On the other hand, when L value is 1, we can have ML value starting from -1, 0, plus 1. Total of 3 different values. Now coming to MS value. MS value will be always plus half or negative half. So that is applicable to both L is equal to 0 or L is equal to 1. So what does this signify? So these are the quantum numbers related to the electrons present in the L shell. So L shell can have two subshells or two orbitals. One is called the S and the other one is called the P. Now what does ML denote for? 0. ML, if it is equal to 0, it denotes that the L value is 0 and ML value is 0. It denotes that there is only one type of s orbital in this second orbit. Coming to ML is equal to -1, 0, plus 1. So here you find that L value is 1. So that denotes that it is a p orbital. P orbitals can have three different varieties. If it is px, pz and py. So we have three different types of p orbitals. We have learned earlier that for every type of orbital, the maximum capacity of electrons will be 2. So here we have two different subshells. The first one is 2s. Second shell contains an orbital which is s, or it can also have 2p. 2p can be 2px, 2pz and 2py. So here maximum of 2 electrons can be there, whereas in 2p we can have 2 plus 2 plus 2, total of 6 electrons. So what will be the maximum capacity of the shell here? 2 electrons this side and total of 6 electrons this side. So 2 plus 6, total of 8 electrons can be accommodated. So you find that when we depict the orbital diagram, here you find that 2s is having only one type and the maximum number of electrons possible will be 2 here. Whereas in 2p, you find that the p orbitals are of three different varieties: px, py and pz. Pz will have value 0. So one is px, the other one is py. So you have maximum of 6 electrons possible here. So in total we have total of 8 electrons and that is the maximum capacity of the second orbital. Hope it is clear. Now we shall see the quantum numbers related to n value equal to 3. When n value is 3, the shell is known as M shell. So when n value is 3, what are the different values for L? L can start the value starting from 0, 1 and 2. If L value is 0, it denotes s orbital. L value is 1 means it is p orbital. L value 2 means it is d orbital. Now check the values for ML. ML, when L value is 0, we have only one value, that is ML0. ML for L value is equal to 1. It can have three different values. Which are the different values? -1, 0, +1. So that means p orbitals are of three different varieties: px, pz py. And then we have the next one when L value is 2. When L value is 2, ML values can be -2, -1, 0, +1 and +2. What does it mean? There are 5 different types of d orbitals. All these orbitals can have a maximum of 2 electrons. That means each and every orbital present in the shells are having a maximum capacity of 2 electrons. And evidently for MS, always the values will be only 2 values, +½ or -½ So we shall find out what are the different orbitals present in M shell. Orbitals present in M shell are 3s, 3p and 3d. So we have only one variety of s orbital. So here we can have 3s, that is one orbital. 3p, three different varieties are there, that is px, py and pz. So all are having equal energy, so it is represented by 3 different boxes which are joined together, which means that it is having equal energy, and such orbitals we call it as degenerate orbitals. So p orbitals are examples of degenerate orbitals. Coming to 3D, what did we learn in 3D? We have total of 5 different orbitals. So 3D orbitals are of 5 different types. 1, 2, 3, 4, 5. So you find that 3D orbitals can have maximum of 10 different electrons because each box can accommodate a total of 2 electrons. So these are also examples of degenerate orbitals. So what will be the maximum capacity of the M shell? The maximum of 2 electrons can be accommodated in s orbital, maximum of 6 electrons in the p orbitals and maximum of 10 electrons in the d orbitals. So total of 18 electrons can be accommodated in M shell. So tell me, what are the possible quantum numbers for the N shell? If it is N shell, we have N value is equal to 4. When N value is 4, what are the possible values for L? It starts from 0 and it ends with the value 1 less than the N value. So it can have 0, 1, 2 and 3. What does L value 0 denote? It is an s orbital. What does L value 1 denote? It is a p orbital. L value equal to 2 denotes it is a d orbital, and L value is equal to 3 denotes it is an f orbital. When L value is 0, what are the possible values of ML? ML can have value only one value, which is 0. That means S is only of one variety. Now coming to L is equal to 1. ML can have 3 different values because it starts from -1, 0, +1. So P will have 3 different varieties, Px, Py and Pz. And coming to L value equal to 2, ML can have values starting from -2, -1, 0, +1 and +2. What does it mean? There are 5 different types of d orbitals. And coming to the last one, when L value is 3. L value 3 means it denotes f orbital, and you have ml value starting from -3 to +3. So -3, -2, -1, 0, +1, +2 and +3. So the possible orbitals of n value is equal to 4 are 4s, 4p, 4d and 4f. We shall see what will be the maximum capacity. 4s is only of one variety. 4p on the other hand are of three different types: 4px, 4py, 4pz. 4d will have total of 5 different orbitals. 1, 2, 3, 4, 5. So here we have 4d orbitals. There are 7 different types of 4f orbitals. One, 2, 3, 4, 6, 7. So 4f, 7 different varieties are there. S orbitals, which are spherical in shape, are of only one variety. P orbitals can be of 3 varieties. It can be px, pz, py. 4d orbitals are of 5 different varieties. It is dxy, dyz, dxz. Then we have dx square minus y square and dz square. And all we know for f orbitals or the f orbitals is that there are 7 different types of f orbitals which are having a complicated structure. So coming to the shapes, s orbitals are spherical in shape, p orbitals are dumbbell in shape, d orbitals are having double shape, and f orbitals are having a lot of lobes which are difficult to show on a two-dimensional paper. So we say that it is having a 3D structure. As a result, the maximum capacity of s orbitals becomes 2. P orbitals, 3 varieties are there, so total of 6 electrons can be accommodated. D, there are 5 different varieties, and so there will be maximum of 10 electrons accommodated. F orbitals are of 7 different types, so maximum of 14 electrons can be accommodated. As a result, the N shell can have total of 2 electrons in S, 6 electrons in P, 10 electrons in D, and 14 electrons in F. That is, maximum of 32 electrons can be accommodated. Hope you have understood. We shall discuss the shape of orbitals. S orbitals are spherical in shape. This is x axis, y axis and z axis. So this is a spherical orbital. P orbitals are dumbbell in shape. So we have 3 varieties. If it is along the x-axis, it is called px. If it is along the y-axis, it is called py. And if it is along the z-axis, It is called pz. Coming to d orbitals, there are 5 different types of d orbitals. D orbitals are having double shape. We have dxy, dyz, and dxz, which are of similar types. Then we have dx square minus y square, and the last one is dz square. All are double dumbbell in shape. We shall see dxy. So if it is dxy, you find that the dumbbells will be arranged in between the axes x and y. So we have the shape like this. Now coming to YZ. When they are arranged, we have the lobes arranged in between the axis, and same way we have dxz, where x and z will be arranged in between the axis. We have the lobes arranged. All these are double dumbbell in shape. Coming to dx square minus y square. Dx square minus y square is peculiar in the sense that the lobes will be arranged along the axis. So we have x-axis and y-axis. When the lobes are on the axis of x and y, we have dx square minus y square. Coming to dz square. So dz square is also a double dumbbell shape. Here you find that one of the lobe will be arranged like this. So this is dz square. So dz square, along the z-axis, the lobes will be arranged, and here we have the x-axis. So here you find that it will be arranged or protruded in front and behind. So it is also double dumbbell in shape. F orbitals, on the other hand, are having three-dimensional structure. So it is difficult to depict the structure which is three-dimensional on a two-dimensional paper. So we have learned today that there are 4 main types of orbitals. The names being S, P, D and F. We have S, which is of only one variety, P, which are of 3 different varieties, D, there are 5 different varieties, and F, there are 7 different varieties. The maximum capacity of S orbital is 2. Maximum capacity of p orbital is 6. Maximum capacity of d orbital will be 10, and f orbitals can accommodate only 14 electrons at a time. Hope you understood. Thank you.